Now we need to move on and define extraneous variables. Look at this definition while I take a sip of water. Okay, an extraneous variable is any other variable in your experiment that is not your independent or dependent variable. So, because you're going to define, this is my independent variable, this is my dependent variable, and then anything else going on in your study, any other variable, we call extraneous. So here are a bunch of possibilities for extraneous variables. So let's look at this first one. Look at this column. Teaching method was our independent variable. Test scores was our dependent variable. So anything that you put here, it cannot be teaching method because that's taken. It can't be test scores because that's taken. So it has to be some other variable. So in this particular experiment, maybe we could say, well, sex of the teacher, that's another variable that could be present. Sex of the student. How about the student's GPA? How about the professor's experience teaching? What about the year, the status of the student? You see how all of these are variables that could exist in the experiment? And these then would be called extraneous. They're something other than the independent or dependent variable. What about this one? Again, type of test was our independent variable. Anxiety level was the dependent variable. And then we have all of these. So all of these variables could exist in the study, and they could be present. Again, some of them are repeated from over here, like sex of the student. What about pre-existing anxiety levels, right? So we're looking at anxiety levels during a test, but what about pre-existing levels? So some people are just generally anxious to begin with. GPA is another extraneous variable that might be present. Testing location, time of day. These are all variables that are not the IV or DV in our particular study, but could very well be present, and so we call them extraneous variables. What about teacher's sex and the teacher's sex and the effect it has on student evaluations? Well, again, when we list all the other variables that might be present, we can't use teacher's sex or student eval. These have already been taken. This is your independent variable. This is your dependent variable. But these are all other variables that could very well be present. So these are all extraneous variables. And the last example, vape juice flavor was the independent variable. Number of puffs per day was the dependent variable. So what are some other variables that might be present? Well, what about the sex of the vapor? What about the specific vaping device? They're not all created equal. What about the size of the vape cloud? Some devices, when somebody puffs on that device and then exhales, it creates this gigantic cloud, and others are far more discreet. What about years somebody's been vaping for and time of day? So these are all extraneous variables that could be present in that particular study. All right. The next variable we have to define is called a confound. Now, this definition here might not make sense, but I'm going to show you using the previous 4 scenarios. We're going to run through those examples, and that will help you to understand what a confound is. So first off, excuse me, know that a confound is an extraneous variable. Let me take some water. Okay, it's an extraneous variable that is systematically different between the groups in your experiment. So it's systematically different between the levels of the independent variable, so that the experimenter no longer knows if it was the independent variable or the extraneous variable that produced the effect on the DV. Now again, you might be scratching your head and rubbing your eyes and going, oh my gosh, like what? But look at these 4 scenarios, and I think this will make it clear. And then you can go back to the definition and you can go, oh yeah, I get it now. All right, so here's that first scenario. Remember, this is the independent variable, dependent variable, and all your extraneous variables. So if this was a perfect world, we would manipulate our independent variable, right? Cauchy method. And here are the 2 different levels. And we would run the experiment. We would collect their test scores. All right, so following the online method, we would collect test scores, and face-to-face, we would collect test scores, and we would compare these 2 means to see if they're different. Now, the only way in which these 2 groups should be different from each other is with respect to which group they were in. So these people should only be different from these people, ideally, with respect to which group they happen to be placed into. But what if, by some weird fluke, the sex of the student somehow became systematically different between the groups? So what if, some fluke of nature, most of the people in the online group happen to be male, and most of the people in the face-to-face group happen to be female? So this is an extraneous variable, right? Sex of student, it's in this list. And if it becomes systematically different between our 2 groups, now we have a problem. Because if we do see a difference between the 2 means, what might explain that difference? It could be the teaching method, but it might also be the sex of the student. So you see how this extraneous variable has become a confound? Think of it this way. Confound rhymes with dumbfound. We are now dumbfounded. This extraneous variable has become a confound because it now dumbfounds us. We no longer know if the difference between the means is because of the independent variable or because of this confound. All right? Now, if these could all become confounds, but only if they are systematically different between these 2 groups. Excuse me. So if, let's say, GPA, if we looked at GPA between online and face-to-face and it was about the same, so the average GPA here for the online group was about the same as the average GPA in the face-to-face group. If GPA is about the same for each group, then it's just an extraneous variable. It's not a confound. It can only be a confound, again, if you see a systematic difference between the 2 groups. So most of the online group was male, most of the face-to-face group was female. So let's run through the other scenarios. Again, we have type of test was the independent variable, anxiety levels is the dependent variable. In an ideal world, we're going to take type of test and we're going to manipulate it by creating these 2 levels, open and closed book. Those are our 2 levels. And we're going to test participants. We're going to get their scores, anxiety scores. So the anxiety scores in the open book test, anxiety scores in the closed book test. And we're going to calculate the mean for each, and then we're going to see if they're different. Now, if they are different, in an ideal world, the only way in which this group should have differed from the people in this group is with respect to the independent variable. Okay, so these people are identical to these people, except this group was in open book category and this group of people was in the closed book category. Now, what if GPA, one of these extraneous variables, what if GPA, for whatever reason, became systematically different between our 2 groups here, such that most of the people in this open book group had a low GPA. Most of the people in this closed book group had a high GPA. Now, if we see a difference between the means, do you understand why we've become confounded or dumbfounded, I should say? We're dumbfounded because we have this confound. This is an extraneous variable that is systematically different between the groups. So now, when we see a difference between these means, we don't know, is it because of open versus closed book, or is it because of low versus high GPA? We have that confound. GPA is the confound, and now we are dumbfounded. Another example, right? Teacher sex, the independent variable, does it have an effect on student evaluations? Well, to test this, we're going to manipulate teacher sex by creating these different levels, male, female. And at the end of the semester, we have a group of people, right, that had the male teacher and a group of people that had the female teacher. And we're going to look at the student evaluation scores for each group, calculate the mean. So this is the mean student evaluation score for everybody who had the male teacher. And this is the mean student evaluation score for everybody who had the female teacher. And if this is the only way in which people differed, then we could say, yes, the reason why these two means are different is because one group had male teachers and one group had female teachers. But what if grade in the class happened to be systematically different between our two groups, between our two levels? So what if we found this? Most of the students in the male teacher group had a low grade in the class. So let's say a C or lower, most of them. And most of the people who had the female teacher ended up with B or higher in the class. Now you see how this extraneous variable is systematically different between our two groups? So if we do see a difference between the means, the student evaluation means, if they're different, how do we know why they're different? Maybe they're different because of the male and female teacher, right? This group had male teachers, this one had females. So maybe they're different because of teacher sex. But maybe they're different because of the grade earned in the class. Grade earned in the class is the extraneous variable that became systematically different between our groups. So this extraneous variable has become what? A confound. Confound rhymes with dumbfound. We're dumbfounded. We don't know anymore why the groups are different. Then the last example, right? This is the vape juice flavor study having an effect on puffs per day. Again, what we would do is we take our independent variable, create these different groups. We call that manipulating the independent variable. We've got 3 groups here. And then we have them vape for a certain length of time, and we figure out the number of puffs. All right, so maybe we just have them vape throughout the day, and we count how many total puffs the no flavor group took, fruit flavor, complex flavor. And if this is the only way they differed, okay, so they were alike in every which way, shape, or form, except these are people were in the none group, these were in the fruit flavored group, and these are in the complex flavored group. If that were the case, then we could relatively safely conclude that the reason why these means are different, the mean number of puffs, is because of vape juice flavor. But what if? What if, for whatever reason, this extraneous variable became systematically different among our 3 groups, such that, for whatever reason, where's my cursor? Here we go. The people who were in the no flavor group, their vape clouds on average were pretty small. So most of the people had small vape clouds. And then for the fruit flavored group, most of the people in this particular group produced medium-sized clouds. And in the complex flavored group, most of the people produced large vape clouds. All right, so now we've got a problem. If we see a difference between these three means, what accounts for the difference? Is it the independent variable, none, fruit, complex, right? Those were the three levels. Or is it the size of the vape cloud? Vape cloud, the extraneous variable, because it's systematically different between our three groups, has become a confound. Confound rhymes with dumbfound. We no longer know why our means are different from each other.